The rectangular arrangement of elements in rows and columns is called as a matrix. The horizontal lines are called the rows and the vertical lines are called as the columns. The order of a matrix will determine the number of elements present in the matrix. Usually the order is defined as rows into column. A matrix having one row means row matrix. A matrix having only one column is called as a column matrix. Square means equal. If the number of rows and number of columns are same, then such a matrix is called as a square matrix. Hello dear students, welcome to this session of Mathematical Foundation class of first semester B.Ca. I am Mr. Niranjan, Faculty, Department of Computer Science, Vidhyaashram First Grade College, the Temple of Excellence. Today in this session, I am going to discuss regarding the first unit in Mathematical Foundation for first semester B.Ca of Mysuru University. That is, the first one is the matrices. In the first unit, you are going to study regarding the matrix. Now, matrices. So here, in this session, I am going to discuss regarding the definition of a matrix and the types of matrices and formation of matrices. Now, let us come to the definition. So, matrix. A matrix is nothing but the rectangular arrangement of elements. A matrix is a rectangular arrangement of elements in rows and columns. The rectangular arrangement of elements in rows and columns is called as a matrix. The horizontal lines are called the rows and the vertical lines are called as the columns. So, the rectangular arrangement of elements in rows and columns. These horizontal lines are called as the rows. These are called as the rows, and the vertical lines, these are called as the columns of a matrix. So, therefore, the horizontal lines, these are called as the rows. 1, 5, minus 9 is first row, 2, 4, 5 is the second row. First row, second row, and the column, first column, second column, third column. 1, 2 comes in the first column, 5, 4 comes in the second column, minus 9 and 5 in the third column. So, the rectangular arrangement of elements in rows and columns. See here, this is first row and second row, and this is third row. These are called as the rows, first row, second row, third row, and they are called as the columns, first column, second column, and third columns. They are called as the columns of a matrix. So, this matrix contains 2 rows and 3 columns. This contains 3 rows and 3 columns. So, the horizontal lines of the elements are called as the rows and the vertical lines of elements are called as the columns of a matrix. So, a matrix is nothing but the rectangular arrangement of elements in rows and columns. The horizontal lines like this are called as the rows and the vertical lines are called as the columns. Let me take one more example. So, usually the matrices are represented by the capital letters like A, B, C or X, Y and Z or P, Q and R. So, let us consider A is equal to 1, 2, 3, 4. This is a matrix. Here this is first row and second row. Similarly, this is called the column, first column and second column of a matrix. So, this contains 2 rows and 2 columns. One more example, let us take back matrix B is equal to 1, 2, 3, 4. This is also a matrix. This contains 1 row, 1, 2, 3, 4 columns. Another matrix, let us write matrix C is equal to 2, 4, 1. This is also a matrix which contains first row, second row, third row and first column. So, these are called the examples for matrices. Now, by knowing this, let us know regarding the order of a matrix. Now, next one is the order of a matrix. So, the order of a matrix will determine the number of elements present in the matrix. Usually, the order is defined as rows into column. The number of rows into number of columns is called the order of a matrix. The order of a matrix is defined as number of rows into number of columns. So, order is always equal to number of rows into number of columns is called the order of a matrix. So, a matrix having m rows and n columns is denoted as m into n, m cross n. So, a matrix having m rows and n column is denoted as m cross n. That means, a matrix, the order of a matrix is nothing but the number of rows into number of columns will give the order of a matrix. Now, let us consider for example, A is equal to, how many rows are there? This is first row, second row and third row. There are 3 rows and how many columns? First column and second column. So, the order for this is 3 into 2. This is a matrix of order 3 rows 2 columns. If we come to this, this contains 2 rows, 2 columns. Therefore, order for this matrix is 2 into 2. So, this contains 4 elements and this contains 6 elements. So, here the order is nothing but the number of rows into number of columns will give the order of a matrix. In general, if a matrix of order m into n, m rows and n column is denoted like this, A is equal to, so m rows, suppose if a matrix contains m rows, let us write A11, A12, A13, etc., A1n and A21, A22, A23, A2n, A31, A32, etc., 3n, last term AM1, AM2, AM1, AM3, AMn. So, this is a matrix which contains m rows and n columns. So, usually for constructing a matrix, we are going to use this 3 rows, 3 column, A11, A12, A13, A21, A22, A23, A31, A32 and A33. If it is 2 rows, 2 column, we are going to consider A11, A12, A21 and A22. So, this is how we are going to write the order of a matrix. So, in general, so the order of a matrix is equal to number of rows into number of columns. Rows into columns will give the order of a matrix. Now, let us come to the next very important concept, types of matrices. So, in types of matrices, for the point of examination, you may get one definition for 2 marks. So, usually we will expect one 2 marks question from a definition, that is types of matrices. Now, let us come to the first one, row matrix. Row means a matrix having only one row. A matrix having only one row is called as a row matrix. Let us consider, for example, if A is equal to 1, 2, 3, this is a row matrix of order 1 into 3. And this is a row matrix of order 1 into 2, B is equal to 3, 2. So, a matrix having only one row is called a row matrix. Let me take one more example, 4, 3, 2, 5, 1. This is a matrix of order, it contains one row, 1, 2, 3, 4, 5 columns, one row, 5 columns. Another matrix, let us take one more example, 4, 6, 7, 8. This is also a row matrix which contains only one row, but the number of columns are 4. One row, 4 columns, this is called a row matrix. In general, a matrix having only one row is called as a row matrix. Now, let us come to the next one. Next one is the column matrix. A matrix having only one column is called as a column matrix. A matrix having only one column is called as a column matrix. A matrix having one row means row matrix. A matrix having only one column is called as a column matrix. Let us consider, for example, if A is equal to A, B, C, this is a column matrix of order 3 into 1. This is also a column matrix of order 3 into 1, 3 to 1, and this is a column matrix of order 2 into 1. So, if you consider one more example, D is equal to 1, 2, 3, 4, 5. This is also a column matrix which contains only one column and the number of rows are 1, 2, 3, 4 and 5. So, this is nothing but 5 rows and 1 column. So, if you consider one more example, let us take another example, matrix A is equal to 3, 4, 6, 7. This is also a column matrix which contains how many rows? 1, 2, 3, 4 rows and only one column. That's it. Okay. Now, by knowing row matrix and column matrix, let us come to the next one is a square matrix. Square matrix. This is very important. Square matrix. Square means equal. If the number of rows and number of columns are same, then such a matrix is called as a square matrix. A matrix in which number of rows is equal to number of columns is called as a square matrix. A matrix in which the number of rows and number of columns are same. A matrix in which number of rows is equal to number of columns is called as a square matrix. So, usually square matrix of order 2 rows 2 column, 3 rows 3 column, 4 rows 4 column, 2 into 2, 3 into 3, 4 into 4, like that. Now, let us consider, for example, A is equal to 3, 2, 1, 0, 1, 2, 3, 2, 1. This contains 3 rows 3 column. Another example, B is equal to 2, 3, 1, 4, 1. This is a square matrix of order 2 cross 2, and whereas C is equal to, this contains only one element, 1 into 1. So, this is a element. So, these are all example for square matrices of order 1 cross 1, 2 cross 2, 3 cross 3. So, in a square matrix, let us consider a square matrix. The element from left top corner to the right bottom corner are called as the principal diagonal element. So, in this example, 1, 3, 4, 5, 2, 6, 7, 8, 9 is a square matrix of order 3 rows 3 column. The elements 1 to 9 are called as the principal diagonal elements. So the elements from left top corner to the right bottom corner are called as the principal diagonal elements. In this example, 1 to 9 is the principal diagonal element. In the above example, 1 to 9 are called the principal diagonal elements, and the 7 to 4 are called as the secondary diagonal elements. So the elements from left top corner to the right bottom corner are called as the diagonal elements. So you got an idea. What is a square matrix means? If the number of rows is equal to number of columns, then it is called a square matrix. These are example for square matrices. Now what are diagonal elements? In a square matrix, the elements from left top corner to the right bottom corner are called as the principal diagonal elements. Let me take one more example. If A is equal to 3, 4, 6, 7, 8, 9, 3, minus 4 and 5. So in this example, these 3, 8 and 5 are called as the principal diagonal elements or leading diagonal elements, and 3, 8, 6 are called as the secondary diagonal elements. Right. Now, let us, by knowing this square matrix and diagonal elements, let us come to the next type, that is called a diagonal matrix. What is a diagonal matrix? It's a square matrix first of all. A square matrix A is said to be diagonal matrix if all non-diagonal elements are zeros. All the elements are zeros except the principal diagonal elements, except the diagonal elements. All non-diagonal elements are 0. So 2, 0, 0, 0, 4, 0, 0, 0, 5 is an example for a diagonal matrix. Here all the elements are 0 except this principal diagonal element. All non-diagonal elements are zeros. Then it is called as a diagonal matrix. So this is an example for a diagonal matrix of order 3 rows and 3 columns. So all the elements are zeros except the principal diagonal elements, then it is called as a diagonal matrix. Let us take one more example for a diagonal matrix. It is a square matrix in which all the non-diagonal elements are 0. So 3, 0, 0, 0, 5, 0, 0, 0, 7. This is also an example for a diagonal matrix. Now, let us take one more example of order 2 rows 2 column 4, 0, 0, 5. This is also an example for a diagonal matrix in which all the non-diagonal elements are zeros. Okay, hope you got an idea. Now, let us come to the next. By knowing these diagonal elements, diagonal matrix, let us come to the next, scalar matrix. Scalar matrix. This is very important. Scalar, just a constant. So it is an example for a diagonal matrix. A diagonal matrix is said to be a scalar matrix if its diagonal elements are equal. First of all, it is a diagonal matrix. Diagonal matrix means all the non-diagonal elements are 0. If the diagonal elements are same, then it is called a scalar matrix. So a diagonal matrix is said to be a scalar matrix if the diagonal elements are equal. 5, 0, 0, 5 is an example for a scalar matrix of order 2 rows 2 column. 3, 0, 0, 0, 3, 0, 0, 0, 3 is an example for a scalar matrix of order 3 rows 3 columns. So these are the examples for scalar matrices of order 2 and 3. So very important, you may expect this definition for 2 marks. Define a scalar matrix with an example. A diagonal matrix is said to be a scalar matrix if its diagonal elements are same or equal. 3, 0, 0, 0, 3, 0, 0, 0, 3 is an example for a scalar matrix. So otherwise, you can also define a scalar matrix. It is a square matrix in which all the non-diagonal elements are zeros and the diagonal elements are same. Then it is also called as a scalar matrix. Let us take one more example. C is equal to 4, 0, 0, 0, 4, 0, 0, 0, 4. This is also an example for a scalar matrix of order 3 rows and 3 columns. Now, these are all examples for diagonal matrices. All scalar matrices are examples for diagonal matrices, whereas all diagonal matrices are not scalar matrices. For diagonal matrix, all non-diagonal elements must be 0, whatever may be the diagonal elements. Whereas for a scalar matrix, all diagonal elements must be same. So therefore, the conclusion is all scalar matrices are example for diagonal matrices, whereas all diagonal matrices are not example for a scalar matrices. Now let us come to the next concept. Next one is the identity matrix. Next type of matrix is called as a identity matrix, or it is also called as an unit matrix. Unit means what? 1. So, a square matrix in which all the principal diagonal elements are equal to 1 and other elements are zeros is called a identity matrix, and it is denoted as I, capital I. I is the representation of an identity matrix. So, all the elements are zeros except the principal diagonal elements, and the principal diagonal element must be equal to 1. So, that is 1 0 0 1 is an example for an identity matrix of order 2 rows 2 column. 1 0 0 0 1 0 0 0 1 is an example for an identity matrix of order 3 rows and 3 column. So, a square matrix in which all the principal diagonal elements are equal to 1 and other elements are zeros. It is also an example for a scalar matrix 1 0 0 0 1 0 0 0 1. This is also an example for a scalar matrix. That means all identity matrices are example for scalar matrices, whereas all scalar matrices are not identity matrices, provided if the diagonal elements are equal to 1 and the non-diagonal elements are zeros. So, all the elements are zeros except the principal diagonal element is called an identity matrix. Let us take one more example. C is equal to 1 0 0 0 0 1 0 0 0 0 1 0 0 0 0 1. This is also an identity matrix of order 4 rows and 4 columns, and it is denoted as I. I is equal to 1 0 0 0 1 0 0 0 1 0 1 0 0 0 1 is an example for an identity matrix of order 4 rows and 4 columns. Now, let us come to the next one. The very important one is null matrix or a zero matrix. The next type is zero matrix or a null matrix. Zero means a matrix, whatever may be the order, a matrix in which all the elements are zeros, all the entries are zeros. A matrix in which all the elements are zeros is called as a null matrix or a zero matrix, and it is denoted as 0. So, these are an example for zero matrices 0 0 0 0 0. This is of order 1 into 1, and this is of order 2 into 2. This is of order 2 rows and 3 columns. So, a null matrix is denoted like this. This is also an example for a null matrix of order 3 rows and 3 columns. So, a matrix in which all the elements are zeros, then it is called a null matrix. 0 0 0 0 0 0 0 0 0 is an example for a null matrix. A null matrix is usually denoted by O, that is 0. That's it. So, these are all the types of matrices. So, row matrix, column matrix, then square matrix, diagonal matrix, scalar matrix, then zero matrix and the identity matrix. These are few types of matrices. Next, now let us come to the next concept, construction. So, problem, let us take simple problems for 2 marks. So, in the examination they may ask like this: if a matrix has 8 elements, what are the possible orders it can have? So, actually I told now itself just the order of a matrix will determine the number of elements present in it. So, a matrix has 8 elements. So, if a matrix has 8 elements means then the possible orders are 1 into 8. 1 into 8 is 8. Again 2 into 4, 2 rows 4 column. Again then 4 into 2, 4 rows 2 column, and 8 into 1. So, these are the possible orders: 1 into 8, 2 into 4, 4 into 2, and 8 into 1. 1 row 8 columns, 2 rows 4 columns, 4 rows 2 columns, and 8 rows 1 column. These are all the possible orders for a matrix having 8 elements. Now, second one, write all the possible orders of a matrix having 24 elements. For a matrix having 24 elements and 13 elements. Let us write for 13 elements. For 13 elements, what are the possible orders? Only 2 possible, 1 comma 13 and 13 comma 1. These are the 2 orders. 1 into 13 and 13 into 1 are the possible orders. For this problem, for elements having 24 elements, for 24 elements, what are the possible orders? 1 into 24, again 2 into 12, 12 to the 24. So, multiple of 8, 3 into 8, again from 4, 6, 4, 4, 6, you won't get 5, again 6 into 4, 6, 7, no, 8 3s are 8 into 3, again 12 into 2 and 24 into 1. So these are the possible orders. See, the possible orders are 1 into 24, 2 into 12, 3 into 8, 4 into 6, 6 into 4, 8 into 3, 12 into 2 and 24 into 1. These are the possible orders for a matrix having 24 elements. That's it. Okay. So if you multiply, you will get 24 elements. 12 2s are 2 into 12 is 24, 8 3s are 24, 6 4s are 24, 12 2s are 24, 24 into 1 is 24. That's it. Now you got an idea. Now let us come to the next set of problem. Now construction of matrix. Construct a 2 cross 2 matrix whose elements are defined as A is equal to Aij, where Aij is equal to I by j. Now we have to construct a matrix of order 2 rows 2 column. 2 rows 2 column is 2 rows A11, A12, A21 and A22. So what is the condition given? Matrix A is equal to Aij is of the form I divided by j. I divided by j means A11, that is 1 by 1, 1 by 2, 2 by 1 and 2 by 2. So this is equal to 1 by 2 is 1, 1 by 1 is 1, 1 by 2 is 1 divided by 2 by 1 is 2 and 2 by 2 is equal to 1. This is a matrix of order 2 rows 2 column whose elements are of the form I divided by j. That's it. So this is also important for 2 marks, the construction of matrices. Now let us come to the next problem. Now what is the problem given? Construct a matrix of order 3 rows 4 column given by A is equal to Aij, where the elements of matrix are 2i minus j. Let us write B is equal to 3 rows and 4 column. The elements are A11, A12, A13, A14. Again A21, A22, A23, A24. Again A31, A32, A33, A34. So this contains 1, 2, 3 rows and column 1, 2, 3, 4 columns. Now write down the elements. What are the elements given? 2i minus j, 2i minus j. 2 into 1 minus 1, 2 into 1 is 2 minus 1, again 2 into 1 is 2 minus 2, again 2 into 1 is 2 minus 3, again 2 into 1 is 2 minus 4. This is first row. Now second row, first element is 2 here. 2 into 2 is 4, 4 minus 1, 2 into 2 is 4 minus 2, again 2 into 2 is 4 minus 3, again 2 into 2 is 4 minus 4. Now let us come to the third row. What is third row? Contains 3 1, 3 2, 3 3, 3 4. So A31, 3 into 2 is 6 minus 1, again 3 into 2 is 6, 6 minus 2, again 3 into 2 is 6 minus 3, again last element 3 into 2 is 6 minus 4. What is given condition? 2i minus j. So 2i minus j are in the form of this matrix. So therefore simplify this. 2 minus 1 is 1, again 4 minus 1 is 3, 6 minus 1 is 5, again 2 minus 2 is 0, 4 minus 2 is 2, again 6 minus 2 is 4, again 2 minus 3 is minus 1, 4 minus 3 is 1, again 6 minus 3, 6 minus 3 is equal to 3, again 2 minus 4 is minus 2, 4 minus 4 is 0, 6 minus 4 is equal to 2. So this is a matrix of order 3 rows and 4 column. That's it. Hope you followed. So this is how we are going to construct a matrix of given order. Now let us come to the next one. Now that is equality of matrices. Next concept is the equality of matrices. Two matrices A and B are said to be equal if and only if they have same order and the corresponding elements are same. Two matrices are said to be equal if and only if they are of same order, that is matrix A is equal, Aij is equal to Ai. So then we will say matrix A is equal to B. So two matrices are said to be equal if and only if they are of same order and the corresponding elements are also same. So these two matrices are said to be equal. So let us consider example. For example, 2, 3, 4, 5, 2, 3, 5. These two matrices are said to be equal because the order of this matrix is 2 into 2. For this also it is 2 into 2. And the corresponding elements are also same. 2, 2, 3, 3, 4, 4, 5, 5. So then these two matrices are said to be equal. Now come to this problem. If A is equal to x 1 3 y, B is equal to 2 1 3 5, these two matrices are equal. A is equal to B if and only if the value of x is equal to 2 and the value of y is equal to 5. If x is equal to 2, y is equal to 5, then these two matrices are said to be equal. So in general, two matrices are said to be equal, equality of matrices, if and only if they are of same order and the corresponding elements must be same. Now, by knowing this, let us take few problems based on the equality of matrices. Let us take some simple problems. Find the values of A, B and C, D from the following equation. Now, just by equality of matrices, equate it. 2A plus B is equal to 4A plus B and A minus 2B is equal to minus 3. Similarly, 5C minus D is equal to 11 and 4C plus 3D is equal to 24. Now, solving these equations, you will get the value of A, B, C and D. Now, from this equation, from 2A plus B is equal to 4A plus B, transfer this. So what happens? 4A plus B minus 2A minus B is equal to 0. So plus B minus B gets cancelled. 2A is equal to 0. A is equal to 0 by 2 means 0. So the value of A is 0. You are going to get A is equal to 0. Now substitute this value of A in this equation. So from this, from A minus 2B is equal to minus 3. So what is A? 0 minus 2B is equal to minus 3. Therefore, B is equal to minus 3 by minus 2, that's equal to 3 by 2. B is equal to 3 by 2, you will get. Now, A and B is obtained. Now, just find out the value of C and D. Now, if you solve these two equations, you will get the value of C and D. From these two, from 5C minus D is equal to 11 and 4C plus 3D is equal to 24. If you simplify this, by simplifying this, multiply this with 3 and this with 1. Now, just solving these two, 5C minus D is equal to 11 and 4C plus 3D is equal to 24. Just multiply this with 3 and this with 1. So, what we are going to get, I will write here, 5 3s are 15, 15C minus 3D is equal to 11 3s are 33. And this equation, multiplying by 1, 4 into C is 4C. Again, plus 1 into D is 3, 3 into 1 is 3D is equal to 24. Just add, that's all. If you add, plus 3D minus 3D gets cancelled. 15 plus 4 is 19C is equal to, add, we are adding, 4 plus 3 is 7. This is equal to 57. So, therefore, C is equal to 57 divided by 9. So, that's equal to 3. The value of C is equal to 3. Okay. Now, substitute this value of C in this equation. Put C is equal to 3 here. So, what you will get? 3D is equal to 24 minus 4C. That's equal to 24 minus 4 into 3. So, 24 minus 4 3 is a 12. That's equal to 12. So, value of 3D is equal to, therefore, D is equal to 12 by 3 means this is equal to 4. D is equal to 4. So, this is how we are going to get the value of A, B, C and D. So, therefore, what is say? Therefore, A is equal to 0, B is equal to, what is the value of B? 3 by 2. C, what is C? C is equal to, what is C? 3 and D is equal to 4. That's it. Right. So, this is how we are going to get the value of A, B, C and D by equality of matrices. Now, let us take a similar type problem. Now, same type problem. So, find the value of A, B, C, X, Y and Z. Now, by equality of matrices, just equate it. So, here x plus 3 is equal to 0, therefore, x is equal to minus 3, one value will get. Z plus 4 is equal to 6, therefore, Z is equal to 6 minus 4, that is Z is equal to 2, you will get x value, Z value. Again from this, so where is Y? We have 2y minus Z is equal to 3y minus 7, sorry. 2y minus 7 is equal to 3y minus 7. Interchange, just bring this to the right hand side. 3y minus 7 minus 2y plus 7 is equal to 0. 3y minus 2y is 1y minus 7 plus 7 gets cancelled, y is equal to 0. Now, x is minus 3, y is 0, z is equal to 2. Now, find out the value of a, b and c. Now, here a minus 1 is equal to minus 3. Therefore, a is equal to minus 3 plus 1, that's equal to minus 2. A is equal to minus 2. Now, get the value of c, that is 2c plus 2. 2c plus 2 is equal to 0. Therefore, 2c is equal to minus 2. C is equal to minus 2 by 2 is minus 1. C is equal to minus 1 you will get. Similarly, get the value of b. What is b? b minus here. b minus 3 is equal to 2b plus 4. So, transfer this, that is 2b plus 4 minus b plus 3 is equal to 0. 2b minus b is 1b, 4 plus 3 is 7 is equal to 0. Therefore, b is equal to minus 7. So, the value of a is minus 2, b is minus 7, c is minus 1, x is minus 3, y is 0 and z is equal to 2. So, this is how we are going to solve this problem. Okay. So, this is how we are going to solve this problem. Now, let us come to the next problem. So, find x, y and z from the following equation. So, again by equality of matrices, we can write x plus y plus z is equal to 9, equation number 1. X plus z is equal to 5, let us represent this as equation number 2. Y plus z is equal to 7, equation number 3. Now, just take from 1, what is 1? X plus y plus z is equal to 9. Just substitute the value. What is y plus z from 3? This y plus z from 3, y plus z is equal to 7. From equation number 3, just substitute the value of y plus z is equal to 7. Therefore, x is equal to 9 minus 7. 9 minus 7 is equal to 2. So, therefore, the value of x is equal to 2. X is equal to 2. Now, just substitute this value from equation number, from 2, x plus z is equal to 5. So, what is z? Z is equal to 5 minus x, that is 5 minus 2 is equal to 3. Z is equal to 3. And get the value of y then. Now, from this equation, from 3, y plus z is equal to 7. Therefore, y is equal to 7 minus z, that's equal to 7 minus 3, that's equal to 4. Y is equal to 4. So, therefore, the value of x is equal to 2, y is equal to 4 and z is equal to 3. See, if you add x plus y plus z, 4 plus 3 7, 7 plus 2 is 9, you will get the first equation. X plus y plus z, 2 plus 4 plus 3, 2 plus 4 plus 3 is equal to 9, that's it. Now, let us come to the next problem. Next problem is, if x plus y 2, y minus z, x minus y matrix is equal to 6, 2, 5, 8. Find the values of x, y and z. Same, by equality of matrices. By equality of matrices, x plus y is equal to 6, then 2 is equal to 2, y 5 minus z is equal to 5, and another one x minus y is equal to 8. So, from this you can get minus 5 is equal to z, therefore, z is equal to 0 is the first answer. Now, solving these two, x plus y, x plus y is equal to 6 and x minus y is equal to 8. So, add, if you add, what you will get? Minus y plus y gets cancelled. 2x is equal to 8 plus 6 is 14. X is equal to 14 by 2, that's equal to 7. X is equal to 7. Substitute this value in any one of these two equations. From equation number, x plus y is equal to 6. Now, just what is y? Y is equal to 6 minus x. 6 minus, what is x? 7. That's equal to minus 1. So, therefore, y is equal to minus 1. So, therefore, the value of x is equal to, what is x? 7. What is y? Y is equal to minus 1. What is z? Z is equal to 0. That's it. See, if you put x plus y, what is x plus y? X is equal to 7. 7 minus 1 is 6. Similarly, x minus y is 8. X minus y is 8. X is 7. Minus of minus 1 is plus 1. 7 plus 1 is 8. And z is nothing but 0. So, here if you put Z is equal to 0, 5 minus 0 is 5. So this is how we are going to solve the problems. Hope you follow. These are very simple problems. You may expect this type of questions for 5 markers or 3 marks or 2 marks. Okay. So hope you followed this very simple concept. That's all regarding today's session. Let us meet with the different concept in the next class. Thank you. Thank you very much.